So
Perfect. Okay, we're good.
Perfect.
We're
Awesome.
live.
Yeah, so let's start then. So welcome to the Cloud Native South Florida meetup. Great. So this meetup is created for Tri-County South Florida, for people who practice and use Cloud Native technologies and also contribute to open source technologies. And just housekeeping, if you have any questions, please feel free to put on the chat, use the Q&A features, and then also this is pretty like open, dialogue, so, if you have any questions, please don't hesitate. And then also, if any of you guys want to contribute contents in the future, please reach out to Case and myself. And then, we are happy to, host your, an opportunity for you to share your knowledge with the communities. And also, we are planning an in-person meetup in December, so please, check out our official page for more updates. So that's it. So please, Matt, take it away.
yeah, thank you all for having me. I appreciate it. I used to live down in South Florida, so I'm glad to give a little talk to the community down there. Yeah, today we're going to be talking about OpenTelemetry. So part of like my last role was to migrate telemetry, like to migrate from different observability providers, right? So migrating away from things like Splunk and Grafana and onto something like a Datadog, right? And those happen to be the vendors that we chose to migrate, from and to. But the what I want to talk about here is how we kind of used OpenTelemetry to like standardize our telemetry and to enable that migration. So to give some context, the migration started out from like a cost savings perspective, and I know the people that are listening to this, they're probably like, wait a minute, you're migrating away from Splunk, away from Grafana, and onto Datadog, and you're saving costs. How do, right? How do work this, right? Like how do this? Yeah, I totally agree. It's kind of wild to think about it, and I have some I have a pull request that I could show you of like what we kind of did to get that. But the TLDR is it can be done if you're very intentional about the telemetry data you're sending around and how you're like filtering it and processing it and sending it off to Datadog or wherever you're sending it to. So OpenTelemetry is a really, really good fit for that. And it's obviously a really good fit for this meetup because it's a CNCF incubating project still, right? I guess it's still incubating. I don't even remember. But it's a good fit for this. So I kind of want to just talk about that a little bit. So previously, like in our life, we have what 500 or so Kubernetes clusters in production. Each of those clusters are running maybe like 3-ish plus nodes, maybe more. So many hosts in production, many logs, many metrics, many traces, all of that good stuff that has to be sent around. And we were sending that data to Grafana, and where we were running our own Grafana, and like that's or technically Mimir, right? You're sending it to Mimir and you're viewing it with Grafana, whatever. Um, that was fine, honestly. People had a very good experience with that. We were running it, we owned the cost, everything was great. But that meant we were running that service, right? We were providing that service as a like service to our engineering team, and we were responsible for its uptime and whatnot. And that kind of sucks a little bit. And that was one reason of like, okay, we want to stop managing Grafana and just start using a SaaS provider. And Splunk, logs were going to Splunk. Splunk's fine, right? Good query language, pretty complex deployment model, honestly, but a pretty good query language of how to process your logs. Also, though, they were purchased by Cisco, and their prices now went like this, very, very high. So we wanted to get off of that. And we saw this as an opportunity to we were using OpenTelemetry at the time for one small use case for shipping traces around. And the traces were already going to Datadog. So we were looking at what we had. We had Splunk, we had Grafana, we had FluentBit, we had Prometheus, we had OpenTelemetry, we had Datadog. We had all of these tools slash vendors slash providers, whatever you want to call them. And we're like, listen, why are we doing this to ourselves? Let's get everything shipping with OpenTelemetry, and then we can pivot to whichever vendor we want because the data will be standardized. So that's the journey we're talking about. Now, again, the theme here is cost savings, right? So keep in mind that the core theme of this project was cost saving, so that had to be a priority here. And we already had OpenTelemetry deployed, and we were already sending traces with it. So first up really was, can we start sending more data with OpenTelemetry? Can we start sending logs? Can we start sending metrics? Can we do this stuff? And the answer very, very quickly was yes, obviously. OpenTelemetry does support that. They have pretty good support for metrics and traces. That's like the bread and butter of OpenTelemetry. Log support is definitely, hit or miss depending on the libraries you're using or the language or whatever. The logging format is still TBD, so to speak. But it was fine, and we had Fluent Bit sending logs, so we weren't really in a rush to like move the logging stuff to OpenTelemetry. But metrics were like the bread and butter. When we calculated the telemetry data that we were sending per day, 90% of it was metrics and only 10% of it was logs. We were sending like a crap ton of metrics to Grafana every day across the entire fleet, on the order of like 27 terabytes a day of metrics. Like, yeah, no, like really, really a lot. And I forget the number of active series, but it was like in the millions of active series. So obviously, we can't just pivot that and point it at Datadog, because congratulations, you're going to be paying millions of dollars to Datadog if you do that. So as we started looking at this and looking at the data, we're like, okay, how do we use OpenTelemetry to save us here, right? To be very intentional. And what we found was OpenTelemetry provided us what we needed for this in the sense of its filters and its processors, and we'll talk a bit about this in a second. But we also found that the Datadog API was a little frustrating, to say the least, to work with, right? The how Datadog expected the data to come in was a little frustrating. So let's talk about that. Datadog has a concept of integration metrics and custom metrics. And anyone who's in this field and anyone who's ever heard of Datadog probably knows that custom metrics means like pay me, right? Pay me money. And we really wanted to find out before we like went all in on OpenTelemetry and went all in on Datadog, what does this mean for us, right? So we ended up with a pull request, which I put in the I was logged in as the wrong account. Let me switch my account there too, because you're not the only one that manages multiple YouTube channels. So do I. I'll put it in this one. Here you go. Cool. So we ended up with a pull request where we're like, hey, Datadog, we have a lot of metrics that come out of CockroachDB, like on the order of 1,500 plus metrics that come out of CockroachDB. We're sending them fleet wide. There's a lot of them. Can we like get them supported as integration metrics so we don't have to pay a lot of money? And they said yes. And we were like, great, thank you for saying yes. You've just saved us a bunch of money. Are you sure that you want to do this? Because isn't that like an abusive relationship for you? Right? Like, isn't that a problem for you? Like, you're going to take all these metrics and we'll pay less money for them. But they were on board. And like, at first, you think, okay, I can just scrape the metrics from CockroachDB, because CockroachDB emits a Prometheus endpoint. I could scrape them with OpenTelemetry. That's really simple, right? OpenTelemetry has a Prometheus receiver that you can just use, scrape metrics, and I could just send them to Datadog. Well, it wasn't that simple. If you did that, the Datadog would treat them as custom metrics. And the reasoning is, when you want to send metrics to a provider, and I'm going to use a lot of Datadog here, but this is true of any provider, right? If you want to send data to a telemetry provider, you need to know like how they expect to receive that data. Most modern observability platforms can speak, like OpenTelemetry line protocol, like natively, right? Like the Honeycombs, maybe the Axioms, those people, they can speak these like OpenTelemetry natively, and that's great. Datadog doesn't. Datadog doesn't speak OpenTelemetry. They receive everything in their APIs through JSON, right? There's no binary format to send them anything. So when we're sending them metrics, we're sending them like with our OpenTelemetry names, we're sending them with our labels, and they're like, don't know what to do with this. You need to like change the labels to matter, right, to be better, change the names of the metrics to match the integration. Because if you send a metric called like foo.bar and Datadog expects like foo.baz or something, well, congratulations, you're going to be paying for that as a custom metric. So we were like, okay, we can't have a simple like OpenTelemetry pipeline of a receiver, a small processor, and an exporter. We need many processors here, because we need to now filter metrics to make sure we're not sending things we don't need. We need to now process metrics to make sure we actually update the labels, change the names of the metrics, whatever. We need to do all of this. So we did that. We did that. And we ended up with an OpenTelemetry configuration that was 15,000 lines long. Actually, it was like 14,800 and change or whatever. But we say 15K. So we had a bunch of like transform processors, metrics transform processors, all of that stuff, just filter processors. And like it sounds bad to have such a large file, but we generated it, right? We like built it in Go and rendered it to YAML, blah, blah, blah. We did all that. But like imagine doing that without OpenTelemetry, right? You imagine doing that without some sort of standardized tooling that knows how to send this data to all these different providers. If I had to do that with just like a Prometheus scrape, that would be kind of miserable. And I can only send it to the backends that supported like raw Prometheus data. Even though I know the OpenTelemetry data model is like pretty much one-to-one with OpenMetrics, it's not like you can just point that at any vendor, right? So now that we had the data standardized, like the metrics data, this was actually great because we're in control of our metrics, we're filtering, we're processing, we're changing labels, sending it to Datadog, everything's happy. We're not getting billed for custom metrics. We saw the bar drop back down. We're like, great. But another problem came up, and we were like, okay, some hosts in our fleet were using the Datadog agent because during like POC and during like testing, we were evaluating whether we should do the Datadog agent or OpenTelemetry collector for like our standardization. And there was good reasons to choose both, right? It's very easy to be sticky with like the Datadog agent and say, oh, Datadog provides this great agent, let me just use it, and they will give me like I just push a button and the agent sends things over. But it's very easy to spend a lot of money with that, right? You set one Boolean value in the configuration for the agent, and now you're paying like 3x the price. Not fun. So we ended up choosing the OpenTelemetry collector for that, but we still had hosts in the production environment that were sending data using the Datadog agent. And like that sounds fine, right? That sounds like okay, great. 90% of the fleet sending it with OpenTelemetry, like 10% of the fleet or less is sending it with a Datadog agent. What's the problem, Matt? Like who cares? The problem is the observability vendor you choose matters. And Datadog mattered in this case. The metrics product in Datadog has a concept of global metric metadata. So when we were sending this data with OpenTelemetry, and oh my God, we spent hours, maybe days, whatever this was, like hours across days or weeks doing this. We were looking at our data and we used the OpenTelemetry debug exporter. We sent data to Honeycomb as well. We sent data to like our own local file, and we were just like looking at the data and we're like, this data is correct. It is being emitted as a counter. It has the right resource attributes. It has the right label. Like everything's fine about this data. What the hell? What was happening was we were sending a metric to Datadog from the fleet, and the metric was a counter. And people here that are in this field probably know that counters are usually monotonically increasing numbers, which means they just always go up, right? It's like being a gatekeeper and counting people coming in on your little like clicker, right? It always goes up. Well, Datadog doesn't want counters to always go up. How it sends it to the API. They want deltas, right? So they want like the difference between measurements instead of the new measurement, right? So if you measure a count of 1 at time 0 and then a count of like 5 at time 2 or something, they want 4 to be exported to them, the delta. We didn't know that, right? We had no idea. We didn't know that. So we were spending a lot of time with our counter graphs being incorrect. Like literally, like we're trying to rate the counter graphs and get a nice rate for them and alert on them. And we're like, why is this data wrong? So we went to OpenTelemetry, used a debug exporter, and we're like, no, this data is correct. Like the data is correct. Datadog's wrong. And we found out that like the exporter in OpenTelemetry, the Datadog exporter in OpenTelemetry expects deltas, and there's like a cumulative to delta processor that you can use, and blah 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 blah. But again, this was only possible to even really find because we had such good tooling in OpenTelemetry to like see the raw data. Number one, right? I need to see the raw data. I don't want to see post process whatever. I want to see the raw data. And we had good hooks in the OpenTelemetry collector to fix it, right? There were some options in the Datadog exporter that we can enable to fix this, but we can also bring those options into the processor like layer, right? And fix them even before they make it to the exporter. The TLDR is a lot of the like cumulative to delta processors and all that stuff is repeated logic in the Datadog exporter, but like it's better to do that in the processor section rather than leaving it in the exporter side because you know you're not relying on Datadog's code, you're more in control of that. And I guess I should say for those listening, I didn't even like talk about what OpenTelemetry is. I kind of just went to it. But like OpenTelemetry is kind of two things in one, maybe three things in one, depending on who you ask, right? It's a protocol for how data should be flowing through a system, right? It's a protocol that defines that. It's also a tool, right? So you have the collector that knows how to speak this protocol, and it's also an organization, I guess now, right? Like it's a whole organization that defines these standards. So the the interesting thing here was OpenTelemetry gave us a lot of tooling in order to find out what was going on with this and fix it. And the way an OpenTelemetry like pipeline works is you have a receiver to like suck data in, right? To ingest data. You have a processor, which like filters the data, processes it, changes it, transforms it, whatever you want to do. And you have an exporter, which like ships the data somewhere else, right? So it's input, process, output, right? Receiver, process, exporter. So that's how OpenTelemetry works. And every receiver and exporter and processor and whatever in OpenTelemetry is in it's publicly available source code that you can literally download, look at it, clone it, build it, whatever. And that was actually really helpful for us. It was annoying, but it was really helpful because like the docs in OpenTelemetry aren't the greatest right now, but being able to see the source code and say, oh, I know exactly what's happening to my metric data or to this data was helpful. And we did that. So at this point, we were like, okay, we have metrics flowing to Datadog. We found that issue with the cumulative, like the delta processor or whatever. We fixed those things, but then we still had problems, right? We still had problems. We were looking at our graphs and we were seeing like if you reloaded the page, the graphs like legend, like essentially the y-axis, would change and the values would change on the graph for the same metric, right? Literally, like the foo.bar metric, it would be the same. And I was like, okay, what's happening here? What the heck's what's going on? And what happened was this foo.bar metric or whatever it was, it doesn't really matter what the metric was, but it was a counter. And as I said before, counters are meant to be monotonically increasing and you're meant to like rate them and blah, blah, blah. Datadog wants to receive those counters at delta, blah, blah, blah. I said that already. But what happened was data has this concept of global metric metadata where if you and I both send the same foo.bar metric to Datadog and you send it as a counter, but I send it as a gauge, now when Datadog goes to graph that metric, it'll flip flop between like graphing it as a counter or graphing it as a gauge, depending on what was the last one that was received, like in the API. Because in Datadog's world, a metric can only have one type globally. Like of that name can only have one type globally. So if you're sending it as a counter and I'm sending it as a gauge, whoever sent it last is going to tell the Datadog API what type it is, and they win. So graphs were just looking terrible from teams. Like the same different teams looking at the same metric in different ways were getting different results because of this. And we were like, what the hell is going on? Like honestly, we this one was very confusing and very difficult to track down because we're like, what's happening here? Because if you refresh the page, Datadog also has like a summary that you can show you the types of metrics that you're sending. And if you refresh the page, you'll see it flip flopping, like gauge counter, gauge counter. And I'm like, no way. What's happening here? TLDR, this is a case where standardizing on OpenTelemetry like was actually a net positive here because we had those few hosts in our production environment that were using the Datadog agent to send metrics, and the Datadog agent was sending them as like gauges, like certain counters as gauges, whereas the counters were being sent as counters in OpenTelemetry. And we were like, oh no, that has to go. Right? We're like, no, this has to go. So I went on like a crusade to go all throughout the production environment and find every instance of the Datadog agent and remove it in favor of the OpenTelemetry collector. And I did that. And then that problem was fixed. But the point I'm trying to make here with that particular example is standardizing. If you like standardizing is a good thing. And I'm not going to sit here and tell you like everyone should go all in on OpenTelemetry. Like that's not what I'm saying. You should make your decision for yourself and like weigh the pros and cons. But Us going all in on OpenTelemetry in these examples allowed us to standardize on our data, right? Put the same like labels across logs, metrics, and traces, debug our data better when things go wrong, filter out our data and transform it in other ways. So make sure that we're not sending. You can't just send an arbitrary metric and explode our bill, because like we do like a like an allow list based filtering where only the metrics named are allowed to go through. That way we don't just have developers sending arbitrary metrics. And I don't like this. I really don't. I want developers to be able to like send arbitrary metrics and like live their life, right? Like live their life and be developers. But I know we're sending to Datadog, and I can't just let that happen, right? Like I have to be careful of the bill too. So, but OpenTelemetry let us do that. So that's the reason why I say all this. It's a good platform to standardize on. And in addition to like, I know I focus more on the metric side of it, but we also did end up sending logs through OpenTelemetry. We also did end up sending traces through OpenTelemetry, and it's been a great like platform to standardize on so far. Um, I'll pause here for a little bit and answer some questions because I know I like kind of been rambling for a little bit, but I want to give people the chance to ask questions, and I also want to take a swig of water.
No, this is amazing. So, but I mean, for in my opinion, this is better because you actually sharing it through live story. So we're
Yeah,
all learning from that for sure. I mean, I haven't personally integrated Datadog on Hotel, which is all everything that you're basically saying for me. Is like, kind of like, oh wow, I was saved by the bell then because I didn't get into that. So I do have a few questions here, but I'm just gonna ask like couple and then so you can
yeah,
continue. Um, I think you touched upon this one briefly, but I just want to kind of like get it into like a one single kind of answer. It's kind of like so usually is around the challenges because I mean you've been talking about different challenges, but which one was the one that you felt oh shoot this is actually the one that Alltel itself have and we spend the most time trying to get around because I believe that most of the challenge that you've been talking about it feels like Datadog kind of have like not an
yeah.
ideal implementation. Which one have you found on the hotel side that we should be aware and kind of keep in mind?
Yeah. Two come to mind immediately. One, documentation. The hotel documentation is, I'm sorry anyone that works in a hotel, but it's pretty bad. It's really bad actually. Like it's practically non-existent for certain components, right? OpenTelemetry is built on components. Um, and I'm not to say that I know people are working hard on this. I know that. I'm not like throwing shade at all. But I had to read a lot of code to figure out what config I need to pass, what was even possible, what was happening with the data. It's like there's not a lot of docs for it, and that slowed down development speed a lot, like a lot. And I know OpenTelemetry, the collector, it prides itself on like a pretty easy configuration, right? It's YAML, it has nice sections for the different like processors, receivers, all that stuff, and that's fine. But I didn't know what to put in there. Right? I had no idea what to put in that thing. And I'm not even just talking about the Datadog export. I'm talking about all the processors and like everything, all the processors, the OTTL language, right? That little OpenTelemetry transform language that you can use. Had no idea what context to use for certain things, right? Do I do the data point context or the log context or the resource? Like which context do I set here? So just the documentation and the story around just the concepts in OpenTelemetry, right? Because you all know like there's a logs data model, there's a metrics data model, there's a traces data model, and in those there's different like resource like attributes for them, resource attributes, regular attributes, blah blah blah, and like knowing how to kind of like put all that together sometimes was a bit frustrating, right? We spent a lot of development time figuring that out. So that's like the first challenge. The second challenge was performance, and this is going to be half on OpenTelemetry side and half on like the fact that we had to send JSON over the wire. So what we were doing was we're reading like data, right, from either like logs over TCP or Prometheus scrape endpoints over HTTP, whatever. Reading the data, it's now going to be marshaled to the like, or sorry, unmarshaled into the OpenTelemetry format, right? Because after you scrape data, OpenTelemetry will unmarshal it into the OLTP for OLTP, OTLP, one
Okay.
of them. Yeah, pick one. it's gonna unmarshal it into the OpenTelemetry format, right? And that's fine. And then it's gonna take that format and like pass it through the processors and like change it and modify it and do all that stuff. And at the end, depending on where you're sending the data to, right? If you're sending it to like a honeycomb, you could just send the raw OpenTelemetry data because they speak that. But if you're sending it to something like Datadog, or if you're sending it to something like S3 or something, right? Well, now you have to marshal it back to something. Usually it's going to be JSON, right? You're going to have to marshal it back to JSON. And we're seeing a pretty significant CPU and memory like usage with like JSON on Marshall and JSON Marshall. So we ended up forking the OpenTelemetry collector and swapping out the Go's standard library JSON package with like Sonic
Oh
JSON,
yeah.
which I think is
Yeah.
Uber's. I forget who it is. Yeah,
Yes, I
is it Uber's? I don't know if it's Uber's. Whatever. But we ended up swapping out for that, and that literally dropped RAM and memory. Sorry, CPU and memory significantly because we were able to get a profile with OpenTelemetry's debug, like debug thing. You can get like a CPU profile, and we saw that. So again, that's not fully on OpenTelemetry's problem. It's not their problem, right? They're doing what they're doing, but it's things to be aware of, right? When you're operating at such a large scale and you're like receiving data and exporting data, you just need to be mindful of where you're spending your CPU and memory cycles. And that was a problem for us. Because like we can't go to the business and say, hey business, we're going to standardize on the OpenTelemetry collector. And by the way, it uses more CPU and RAM than our previous setup. Like we can't go to the business and say that. They're going to be like, get the hell out of here, right? So we had to make sure that we were doing right by that too.
Oh no, I agree. I agree. And just to piggyback a little bit more on the performance, because that was actually my second question. Is it's basically the reason why I took a note about the performance, because you actually started talking about like how much data you basically were processing at the beginning. Like that's insane, right? So, but of course, every type of setup, they don't not have that many data, right? So you have different layers. But something that I did notice in one of my implementations is like I lost a lot of like packages, a lot of like data were lost. So the performance impact that I got was like I was sending a lot of information. The receiver was not able to handle that, so I was losing a lot of data there. But then when I was fixing the basically the receiver part, then the collector was also getting some issues. So like, do you have that same issue? How you handle that? Like that was part of your experience?
Yeah, we had a couple of issues related to that. One was I think it was on the the filter processor. No, it was one of the processors, and I can't remember which one exactly it was. But basically, the YAML allowed for like an array of like blocks to do filtering or whatever you're doing, and it that was slower than putting like a big like if metric name equals foo and if metric name equals bar and right like making one big ass if statement was more performant than making multiple blocks in the YAML. So there was that. Then there was also like you were saying, configuring like the batch processor and the memory limit processor to like make sure you don't overload your system. We didn't get a problem with like queue backlogs or anything. We did one time where the Datadog exporter couldn't export fast enough for how much data we were like sending it, and all we had to do was basically increase the queue size there. There's like a num
The local
consumers
cache.
setting. Yeah.
So
So
you mean the when you mean the queue, you mean the local cache on the collector, and
yeah,
then
yeah,
okay, gotcha.
yeah. It was like num consumers. I forget what the exact setting one was, but we had to fix that one for the Datadog exporter. And
That one gave me a lot of problems.
yeah, because
Especially when you're doing a
we were
lot of
seeing
filtering.
telemetry
Yeah.
data being dropped. You know that was the problem, and we didn't want telemetry data to be dropped. And like, I think the error was like a time series point couldn't be written. Please figure this out. And like, yeah, we're like, what? What do you mean can't be written? Just write the damn thing. But yeah, that was basically it from performance. Otherwise, it's been fine, right? Like building it, running it has been good. We haven't really ran into a big issue with like the garbage collector or anything. We're pretty mindful of that. Outside of the JSON thing, like I mentioned, and this stuff, performance has been fine, right? Like we haven't had a problem with it. I know a lot of people were very excited about Vector because it's like written in Rust or whatever, and the performance there was really good, but I haven't like looked at the OpenTelemetry collector and it's like, you're the problem, right? Like I haven't had to do that.
So maybe I'm a little naive, but I mean, it's kind of like I think sometimes we put the solution or the I mean the solution of the challenge in the language. But to be honest, at the end, you're sending stuff through the wire, so it's kind of like you're always going to be limited to the protocol and communication that you have, even
Yep.
if you're writing in an assembly. So maybe I'm, like I said, maybe I'm just a little bit naive, but and that's mainly the issues that I've been finding in all these type of system where anything related with telemetrics logs, anything that I need to get out of my system somewhere else, that's mainly what I'm finding the most issues, I guess.
Yeah, this is one thing where like I put the exporter settings in the YouTube chat that I was talking about. This is one thing where you just have to know where you're sending the data, right? We knew we were sending to Datadog for the most part. We were sending to other places too, but the primary place was Datadog, and they have some documentation around like, hey, this API can only accept this like request body size and blah blah blah, and they give you kind of memory and batch settings to use in OpenTelemetry, and that was fine, right? We just use that. But for another provider, you're gonna have to find those limits yourself. Like Honeycomb's been pretty good. They kind of just been able to handle whatever we threw at them when we were doing like testing and whatnot. And again, I think the part of it is they don't have to pay the cost of like Marshall send a larger data on Marshall. Like they just
Yep.
accept the data as it is, and I think that's a great thing. Um, so yeah, it's just about knowing how the data is flowing through the system and like seeing what impact it has. And there's no right answer, right? You just need to know like
Oh yeah, no, no.
just look at it, yeah. And
And,
I agree with what you said.
and based on your case study, basically is so at the end you're dealing with a system that is not fully receiving the data using the collector as it's supposed to be. So you kind of always going to have that bottleneck in a way. So you have to basically decide how much can I process locally before I send it. But at the end, when you send it, you have to wait until it's processing the other sizes. I think that
Yeah,
bottleneck is going to be.
no, I totally agree. And we ended up, so two things I want to cover there real quick. One is we tried to push processing as far early in the pipeline as possible. So
Mm.
if we could process it on the OpenTelemetry collector, we would, right? Like the filtering, the transformations, all that stuff. If we couldn't really do that, then we'll do the post processing like on the Datadog side or whatever. And that could be more expensive depending on what you're doing, right? Datadog might charge for some of that stuff. Logs were kind of free, but like other things could be a little bit more expensive. But that was fine, right? We tried to push processing as early in the pipeline as possible. And second thing I wanted to say is we're not using like the gateway deployment. So OpenTelemetry has like this concept of a gateway, an agent deployment and a gateway deployment. The agent deployment is like OpenTelemetry sitting next to your application or whatever,
Mhm.
sending data to a gateway, which is basically like a load balancer or reverse proxy or whatever for OpenTelemetry, and then that gateway sends to the destination. We were not using that setup. We were, but only for a few services. But for the majority of our deployments, we were not using the gateway setup. We were using the agent setup. So we just
Okay.
had like a Kubernetes daemon set running,
Mhm.
so that one OpenTelemetry pod was scheduled on every Kubernetes node, and anything that was running on that Kubernetes node would send its data to that OpenTelemetry agent, and then that would send directly to Datadog or to whatever.
Mhm.
And like, sure, we probably could have did a gateway deployment and like had just one place where we're sending to Datadog. But that's their problem, man. I don't I don't care if you connect your API with 50,000 clients. That's your problem, dude. Yeah, no, I'm joking a little bit there, but honestly, like that is their problem, right? So
Have you have any experience or have you dealt with cases when you are processing on the edge? Because I think that would be the one. I haven't tried that yet, so that's why I'm asking. Because in the at least when I was doing logs, uh, of course it's smaller devices, less compute power, so you processing is a lot harder. But I haven't tried the open telemetry on those cases, and it's like,
no, but I'm gonna start trying that. Not at the company, no, because everything was running on VMs. We
okay.
had no like edge devices, right? Like we're providing CockroachDB as a managed service for others, so we're running it like on our Kubernetes clusters, so no edge devices. but I have like a couple of like ARM systems here on my desk that like very low powered stuff that I'm going to be running it on, and I'll see. Because you're totally right though, that in those scenarios, it's probably best to take the processing stage and push it to the right instead of the left because you don't have the CPU to do it, or maybe even the memory. You're usually CPU and memory constrained on these lower edge devices, and yeah, I mean, it depends on where you're sending the data, right? In those cases though, I'd probably opt for, instead of like the gateway deployment, like where you have a gateway on the cluster or whatever, I'd probably have like a or OpenTelemetry as a service endpoint, where you spin up like a cluster of OpenTelemetry collectors that has like a public endpoint that listens over gRPC or whatever, and you like send the data there. That's more powerful. That does the processing and sends it to the final destination. I just really don't like sending the I really, really don't like processing the data in the final destination because it's always different.
Yep.
I'd rather just do it earlier, because if you do it in GCP or Datadog or Honeycomb or wherever, like it's always different. I'd rather just do that beforehand.
I like that.
There's no like shame to anyone who does, right? Like
No, no,
you
no.
do you, right? Yeah.
No, I like that. So definitely, if you're doing that testing, I mean, keep us posted because it's something that definitely I would like to
Yeah,
know
yeah.
how it went.
Yeah, I have a couple of Turing Pi boards, which is basically like kind of like a Raspberry Pi but a different chipset. I have a couple of those that I'm testing with right now. I put the link in the YouTube thing. Um, but we'll see. I literally just installed Kubernetes on it, and I have not deployed anything to it yet because I've just been so busy.
I'm gonna ask the last question. I've been the only one asking questions, so I'm gonna let Tim to also ask questions. So, but my question would be like doing kind of like one step back. Because I mean, open telemetry, as you said, comes to basically solve multiple problems in ones, like logs, metrics, all that. So before that, what would be the advantage that you still see with the traditional, let's call it, collectors of logs and metrics, and that you might want to say like, hey, this is what I still see an advantage of these ones that open telemetry should think about, or if it's in any one.
Yeah, that's a really good question. So like we were using FluentBit for logs, and FluentBit is really good at logs. Like it really is. It's a good program. It's a little hard to extend because it's written in C, and like good luck finding good C talent to like do that all the time. Um, the OpenTelemetry, like if you have a solution that's working for you right now and there's no business value in changing it, you're probably good to stay where you are, right? Like don't just go willy-nilly changing things without some sort of business value attached to it, because that's a great way to like not get a promotion, right? Or not like it's a great way to spin your wheels and not do valuable work for the company. But I don't know, there's other solutions out there, right? I think my biggest problem with OpenTelemetry personally is it's kind of I believe in like Honeycomb's observability 2.0
Mm,
mindset of these like wide structured events, right? Where like it's not a trace, it's not a log, it's not a metric, it's an event. It's a wide event which is a bunch of attributes on it. I like that observability. I've used that observability. It's amazing. It requires a lot of effort on your engineering side to do that, and it requires effort on like whatever tool you're using to be good at it. OpenTelemetry's data model is like antithetical to that. You know what I mean? Because like Honeycomb's very much like the three pillars of observability are like the 1.0 way, the 2.0 way is wide events, and OpenTelemetry's like, yeah, here's a three-pillar data model. So like that's one of the things that kind of makes me a little sad about OpenTelemetry. But I think the 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 TLDR there is like make everything traces and put attributes on them. And I know OpenTelemetry is working on like a new event model, a new event model data, event data model. Sorry, I couldn't twist my words there. Um, so yeah, that's one of the things that I don't always like about OpenTelemetry is like you kind of have to find the best data model for your data and use it, right? And like sometimes you just don't. I don't want it to be a log. I want it to just be an event. So
yep.
that's kind of the thing that bothers me a little bit.
Hmm.
And I don't know, there's no other tooling that's maybe better at it. Everyone's kind of doing their own thing. But if you have a tooling that already knows how to ingest these events and ship them around, might be worth staying there, you know?
Interesting. Thank you. I'll leave the floor to
Yeah, I'm happy to answer any questions.
Hi there.
Hey.
So I guess one question that I had, even taking a step back from the scalability of it all, if you have somebody who is just starting out in telemetry and observability, what would you tell yourself years ago, when you were just getting started?
Yeah, that's a good question. I start with observability 2.0. No, I mean honestly though, like, yeah, I would say build this observability into your development process. Try to get away from the print line debugging and even the debugger in certain cases. Like emit telemetry from your application in your development flow and use that to debug it, because that's going to line you up best for when you have to support it in production. You know, it's very easy to say like, oh, I'm just running this locally print line, and I do it too. But if you really push yourself to like even run something locally and like send your telemetry data that way, it'll open you up to be better at developing with telemetry in mind and also troubleshooting later on, and then building those like SLO based alerts and all that other stuff that comes with it. So if I were going to tell my younger self, it would be like stop doing print line debugging and do like build telemetry into the data, especially in the Go. I'm sure maybe most of you are Gophers if you're in the CNCF, and maybe a lot of you are writing Go, especially in Go, because I see this all the time, where they make a package or something, and then it's like a function that doesn't take a context, and then the very next thing they do is update that function and make a breaking API change to make it take a context because they want tracing now. It's like, just start with that, man. Just start there. Yeah, that's what I would tell my younger self.
That's great advice. Thank you.
Yeah, you're welcome. You're welcome.
Context in those should be required.
For real, yeah. Like it's so ingrained into the language, it just needs to just be there forever. Like I've gotten pushback from teammates in the past where they're like, "Why are you adding a context here? You're not using it." I'm like, "Because we will be using it.
We
And you don't
will,
know it
right?
yet." Yeah, we will be using it. But yeah, any other questions, comments? I don't know what like how long you all usually go, so you tell me.
We usually
Or
take
give
you
me
for
a
half an hour.
Okay, yeah.
So we kind of getting close. So no, that was very interesting. So I don't know if we cut you off with your story, but what I would say, like, what are the I'll say the lesson learned out of your your case study, because I mean it's pretty amazing the way that you describe it. So what would be the lesson learned that we can take out of it?
The couple lessons learned, um, during your POC process for different vendors, of like, when you're trying to do migrations or trying to do telemetry and whatnot, make your POC process really robust and write down everything. Cause like, and we wrote down a lot, right? And I had really good documentation. And I presented things well, but there were some edge cases that I wish I would have caught sooner that I didn't catch until like I started sending better data, and I wish I would have caught those sooner. So like make sure those processes are more fleshed out and more robust. Um, using like I didn't have to use OpenTelemetry. We the whole migration was April to August, September, right? So it's a couple months, right? Like whatever that is in months. Um, and that wasn't bad. But honestly, if I just used the Datadog agent, we could have had that migration done like maybe like a month or two. It would have been much faster. But and I'm not saying this from the perspective of don't use the easy tool. I'm saying this from the perspective of me kind of like forcing us to go down the OpenTelemetry route, so to speak, made us better understand the telemetry data that we had, right? Because if I just turned on the Datadog agent and said like do the thing,
Yep.
I'd have no idea what the hell I'm sending. I'd have no idea the format of it. I'd just know nothing about my system. So using OpenTelemetry allowed me to just understand what the heck I'm sending in the first place. So I really that's a learning too that came away from it. And then the final learning is like you can save costs if you are like add if you're detailed about what you're doing and understanding what you're doing, you can save costs. There's so many different ways to save costs with this telemetry data. Tracing, right? You have sampling for tracing. You don't need all of your happy path traces, right? Get rid of the happy path traces, sample them down. You really just need the error ones. Logs. You don't need like starting job, almost done with job, finished job. Like just refactor that code a bit or whatever, or switch it to tracing if you can. Refactor that code a bit, be better, because that's like 3 log events. Like if you're going the honeycomb pricing, that's 3 events now that you have to pay for. Or if you're going the Datadog way, that's like size of the events, like whatever amount of kilobytes that is. So think about that. Um, yeah, those are kind of the things like that I've learned from this whole process.
Hey, Matt. Yep, sorry. I have a question for you. So I came from a background of using something called Observatorium, which is a basically federated Prometheus model. And I'm assuming when you went from using like, pure prom metrics to now doing like OTel, was it a surprise to realize like you had to actually fork the collector and start doing custom stuff? And was that like an unpleasant surprise? Because the payoff is huge. You can ingest all your metrics together, have better analyses of these metrics, but it does come at somewhat of a cost, I'm guessing, right?
Yeah, I mean the surprise when you say we had the fork to collector, what do you mean in that case? Like why did you have the fork to collector in that case?
Well, I think you said, if I'm not mistaken, like you had a really huge config for the collector, and then eventually you forked it and changed some certain things about it. I'm
Oh yeah.
wondering, yeah, at that point, like, was that something you all had foreseen like occurring, or was that like a surprise at the end?
No, we didn't. It was kind of a surprise, but we didn't mind it. We weren't strangers to building the OpenTelemetry collector,
Mm,
and like I say, fork it. We didn't actually have to fork the collector code itself because the collector
mm,
code is really well built in the sense of like to build the OpenTelemetry collector is basically just a YAML file of components that you have to put together, and one of those components was like the Datadog API mapping.
mm.
That's what we forked.
Oh,
So like it was fine, right? Yeah, that part was fine. I know it's like more specific technical details, but that's what we ended up forking. So that was fine for us, honestly. And like the only thing that we got shocked with, at least at first, with the Prometheus um, usage was Prometheus doesn't like dots in your metric names, right? It wants everything to be underscores. So like the metrics were emitted from Cockroach with like dots in it, so it's like foo.bar. But then on the Prometheus endpoint, it's foo_bar. And then we brought it to OpenTelemetry, and Datadog wants it to be foo.bar again. So we rename it back to foo.bar. And it was just like, this is stupid. Why are we doing this? This is a waste of computing resources. Like, come on. So that was the only like surprise, but we knew it, but we like, and then all of our queries had to change, right? Because we came from Grafana, and they were all using foo_bar, and now migrating the queries to Datadog. Now we have to use foo.bar, and we're just like, this is toil. I don't need this in my life, right?
Yeah,
So
yeah,
just things like that.
gotcha.
interesting.
Anyone else? Yeah. No, thank you all. Yeah.
Yeah, thank you.
No, thank
You're a
you.
great storyteller too. I loved it.
Yeah, I mean, you have to be,
Yes,
right?
great.
That's what we're doing here, right?
Sure.
That's why they're called stories.
I got a lot of notes for sure. I always love when people come with actual case studies or like what happened, even if they're
The
not
horror
nerds.
stories.
Oh
Yeah,
yeah,
they're the best
agreed.
ones. I
No,
appreciate
yeah, I
it.
totally agree. And obviously, I wasn't the only one doing this, right? I worked with another really good engineer that him and I paired all the time, and we did a lot of this work. And I'm not, I may be the one here in front of you telling the story, but it was not just me that did this, right? Like there was a team behind us that really helped with all this too. So I can't take all the credit, but we did do a lot, and I did have to, be the bad cop sometimes. So that was fun. But yeah, thank you all for having me. I really appreciate it.
Absolutely. Thanks for coming.
Of course, of course.
Come back anytime too.
For sure, yeah, we'll do. Yeah.
Yeah.
Yeah, that'll be amazing for sure.
Are you all in South Florida? Is this like a local South Florida group here?
Yep. Yeah, we're in South
Nice.
Florida.
Nice. Yeah, I used to live down there. I was telling you, told me. Yeah.
Yeah.
Well, whenever you are here, let us know. We can do it in person. Actually, I think
Heck yeah.
the next one we're gonna do an in-person event, right? He told me the next.
Correct. Yes. Yes.
Yeah.
In December.
I'd love to. Okay.
Yeah, we're gonna be talking about what like OpenStack is the one.
Ooh, OpenStack, that's fun.
I think if I haven't crossed my chords, it's going to be maybe OpenStack, but it might also be about Golang. We have an author of Go that's really excited about that too. Hey, Matt, one last question. So
Yeah.
as an SRE, how often do you find yourself writing in Go? Because like I know a lot of SREs can write Go, but at some jobs, like they're encouraged to not really like write as much code. But it's also cool in like flexible organizations that are like they're able to pivot, like, hey, we can do this better ourselves.
No, that's a fantastic question, and I'm going to answer it with the caveat that I won't be an SRE in like 2 days because I will be starting a new job on Monday, back to software. So I write code again. No, so this SRE role is good. Like this team is good team that I was on. Code is a big part of like the role. Everything we do is written in code. Like sure, there's like the Terraform and stuff that we have to deal with, but all the services we run, all the Kubernetes manifests, all of that stuff is written in Go, and then we use the SDKs to generate the YAML manifests and all that. We don't actually write raw YAML manifests. We don't use Helm. None of that stuff. Everything's written in Go. So we're writing code all the time, right? So it's a good role for that. There is no pressure to write in like a Python or something, just because I think maybe we just have the luck of being at Cockroach where the database is written in Go. It's a very Go centric company, so there is no like pressure to use like a Python or something different. Because everything's pretty much written in Go here. So we write a lot. Like the SREs here at Cockroach write a lot of Go.
Love that. Nice.
And I think that's gonna become like some sort of like a new orange because a lot of the tooling now, like Terraform came with the CDK, something that you now can write Python, Go, JavaScript. The same thing happened with Pulumi. So I think, in my opinion, I will see more SREs writing code rather than DSLs.
I agree. I think that it's almost going to be, it's probably like table stakes at this point to know Go if you're in this sort of field, right? If you're working with Kubernetes, if you're working with SRE sort of field, if you're working with cloud providers, Go is probably the language you're going to be working with or using in, because most of the tools that you're going to be using are written in Go. So when they break, you're going to have to go looking at the code. And I think if you want to be in this side of the field, right, in this area, I think Go is like table stakes now. And like if I'm writing a trivial app or something, I'm spinning that up in Go real quick, right? I have to reach out to an API and do some requests. I'm not using curl or Postman or whatever. I'm writing that in Go. It's 2 seconds. So yeah, that's my opinion on it.
True. There's a lot of rusting oxide though.
I was going to ask that too.
So I mean that's a good question. That's actually where I am headed. So Monday will be my first day at Oxide. And yeah, I'm really, really excited to dive into Rust. I want Rust to feel like Go for me, right? Like the way I reach for Go for a lot of things, I want to switch that to be Rust. So that's gonna be fun. I'm excited and nervous, but it's gonna be good.
Wishing you luck.
Great.
Man.
Yes.
Thank you. Yeah, I appreciate it.
All right.
Yeah, y'all have a good group of people here. I like that. I'm definitely we still have family in Florida, so and my wife's been itching to take a trip down there, so we might have to line one of these up with the events.
Yes, please.
Absolutely. Yeah, that'd be great. I'd love to do that. Plus, really good Spanish food down there. Really. So I'm in, man. Just for that alone, I'm in.
What can I say, man? Vaca frita is what we do.
Why are you saying that's literally my favorite dish? Vaca frita, maduros, bro. That's all I want. I'm Puerto Rican. I got you. Okay.
Nice.
Awesome. Thank you all. I really appreciate it.
No.
Yeah, thank you so much.
Thank you.
Yeah, very welcome. Very welcome.
Yeah, great. Yeah, Chris, do you want to share anything else? You all good?
Nope, I think that's it. It's been a great episode, and Matt, thanks so much for coming. And yeah, we'll catch you all the next time in December.
See you.
All right, bye, y'all.
Thank you all so much.
All right, thank you. Bye-bye.